The wood crossarm, often unnoticed. It is a strong, durable, and essential component in bringing electricity to North America. Few appreciate what it takes to make a wood crossarm. However, the demands of electricity distribution today require a crossarm that is engineered for strength, protected from deterioration, and durable enough for many decades in service. The first wood crossarms appeared in the mid-1800s to carry telegraph wires. With the advent of electrical generation, wood crossarms evolved to carry heavier lines, insulators, and transformers for the emerging transmission industry. As the electrical grid technology advanced, it was clear the wood crossarm needed to be refined and improved. Grading rules were developed to ensure the wood crossarms had consistent strength and stability. Standards for pressure treating wood to protect against decay and insects were created to enhance the crossarm's durability. A variety of wood species were originally used for crossarms. However, many proved to be inconsistent or unreliable. Douglas fir from the Pacific Northwest became the select species for crossarms thanks to its strength and dimensional stability. Also, crossarms made from southern yellow pine found their way to utilities in the South and Northeast. While a crossarm may appear to be a piece of wood attached to a pole, its role as an engineered component is critical in carrying electricity. The loads carried by a crossarm are dynamic and ever-changing depending on conditions. Crossarms must withstand loads and forces from winds, snow, ice, and even damage to nearby poles. Given these potential stresses, wood crossarms must be exceedingly strong. Douglas fir crossarms have a stiffness rating, or MOE, of 1.7 million pounds per square inch. This high rating means the crossarms can handle high stresses without excessive bending. Crossarms have pre-drilled holes to attach them to wood poles and to hold insulators and other equipment. These holes can impact the strength and stiffness. So national standards for wood crossarms specify the dimensions for crossarms, as well as limitations on the size and location of the holes. The wood crossarm today is the product of more than a century of experience and service. Wood specifications, treating practices, and automated pre-drilling have been refined into a long-lasting, reliable component for carrying power and communication services in the 21st century. Wood remains the material of choice for crossarms by utilities throughout North America. In recent years, crossarms made from alternative materials such as steel and composite fiberglass have entered the market. These alternatives are often promoted as stronger, more durable, or more environmentally friendly than wood. Many of these claims, however, are not substantiated and are not backed by the decades of in-service performance found with wood. From an engineering standpoint, comparing alternative materials to wood can be like comparing apples to oranges. Wood offers distinct qualities not found in other materials. As a natural material, wood offers a unique resiliency to take on loading conditions beyond their stated capacities. Wood crossarm standards take this resiliency into account by assigning conservative strength ratings to account for the natural variations. Steel and composite fiberglass crossarms are designed to a much narrower strength variation, so when exposed to extreme loads beyond the crossarm's rating, there is a higher chance of structural failure compared to a wood crossarm of the same strength rating. Utilities today are more aware of their customers' desire for their electrical service to be as environmentally friendly as possible. Using wood crossarms and wood poles offers unique benefits not found in other materials. The wood used to make crossarms is renewable and sustainable. Forest land in the U.S. and Canada has remained stable for the past 50 years, and more than 1.6 billion trees are replanted each year. Pressure treating wood crossarms extends this renewability, as the crossarms remain in service long enough for another tree to grow large enough to become the source for replacement. Wood crossarms and poles also sequester carbon from the environment. There are an estimated 150 million wood poles and 100 million wood crossarms in service today. The carbon held in this wood accounts for 90 million metric tons of carbon dioxide, or CO2, removed from the environment. That is equivalent to the CO2 emissions from burning 10.2 billion gallons of gasoline. Independent life cycle assessments, or LCAs, for utility poles offer insights that apply to wood crossarms as well. An LCA on utility poles confirms that preserved wood utility poles use less energy and resources and have a significantly lower environmental impact when compared to concrete, steel, and fiber-reinforced composite utility poles. The case for using wood crossarms is as relevant today as it has ever been. Wood crossarms have an unmatched record of long-term performance and service. Advances in pressure treating and automated pre-drilling, as well as end plates on crossarms to minimize splits, will ensure longevity and durability. Wood crossarms are made from a sustainable, renewable resource, and forest practices today ensure a supply of wood far into the future. By comparison, alternative materials are much more expensive and far less friendly to the environment. Next time you glance at the top of a utility pole, you can be sure that wood crossarm was made to stay in place day after day, decade after decade, to bring the power and communications we need in the 21st century.